Hey everyone, in this video we're gonna solve a partial differential equation using Python Sympy library. Don't worry if PDE sound intimidating. I'll break it down step by step so you can see exactly how this code works. First, we start by importing Sympy and defining our variables x and y. Then we define u of xy, which is our unknown function. The PDE we are working with is dou square u by dou x square, which is equal to 2xy. This means the second derivative of u with respect to x equals 2xy. Our goal is to find the general solution for u of xy, which is the unknown value. So next, we do the integration. To solve this, we integrate the right hand side with respect to x. Integrating 2xy gives us x square y. But since we are integrating with respect to x, we also add an arbitrary function of y. Let's call it f of y. So now we get the value as dou u by dou x, which is equal to x square y plus f of y, where f of y is some unknown function depending only on y. Next, we integrate again with respect to x. The integral of x square y is x cube y by 3. The integral of f of y with respect to x is simply x f of y. Since f of y is constant in terms of x, and once again we add another arbitrary function of y, call it g of y. So the general solution becomes u x y x cube y by 3 plus x fy plus g of y. And that's our solution. In this code, Sympy prints the solution neatly using pretty print. The final result shows that the solution isn't just one function. It includes arbitrary function f of y and g of y. That's because PDEs often have families of solution and the exact form depends on boundary condition of initial variables. And that's it. We solved the PDE step by step using Sympy. If you found this breakdown helpful, make sure to like, subscribe, and share for more math with Python tutorials. Thanks for watching.